All right, 8.7 is exponential functions. Okay, so we're still dealing with exponents, but it's a little different now. Okay, so we're not doing rules, we're doing exponential. You might have heard someone say they're growing exponentially or something like that. That is what we're talking about here. Okay, so when you have, this is what exponential functions look like. Here are some examples. You could have y equals 5 times 3 to the x power, or you could have, this could be a decimal. Anything could be a decimal, it could be a fraction. You could even say f of x. So anything you see like this one that is a, and it can be a negative in there, times 1/2 to the x or 0.5, all of those things can happen. Now this is the key. You have to remember that when we go to solve it in a little bit, you always do the exponent first. Okay, you always do the exponent first, but we'll talk about that in just a minute, okay? So here you need to sketch these graphs because they're going to come in handy, okay? Now, if you have a graphing calculator, you can use it, but if we're just going to sketch these in a little bit, we're actually going to graph it with points, but I'm just going to show you what they look like, okay? So y equals 2 to the x is kind of our parent graph. It's going to go through 1 right there and then go up, all right? This one, since it's a negative 2, it's going to go down like this. Okay, actually, that's not a straight line. It's supposed to be more like that. Okay. The 1/2 means it's going to start up here and go down. And the negative 1/2 means it's going to start up here. Okay, and if you can't remember that, that's fine, but those will help you on some of the questions on your assignment. Okay, it doesn't matter what these numbers are right now. That's just what they would look like if it's a number greater than 0. So these two numbers are, well, I shouldn't say that, but this number is between 1 and 0. This is between negative or 0 and negative 1. Okay, you can look at that, and that'll help you. Okay. So evaluate y equals f of x, y equals 5 to the x for x equals 2, 3, and 4. So you're just plugging this in. So you're going to want to use calculators on some of them. Okay, so you're just plugging in 2 for x, so that's going to equal 25. The next one, you put in the 3. 5 times 5 is 25, times 5 is 125. Okay. Y equals 5 to the 4th is 625. That's it. That's all you do. Okay, same here. Just pretend, remember, this is just another way to put y. So this is 4 times 3 to the negative 3. Remember, domain is just another word for your x value. So 3 to the negative 3. Okay, so in your calculator, you can put 3 to the negative 3, or we can use our rules. Remember? Okay, because I want this as a fraction. We don't always, sometimes we want decimals, sometimes we won't. So this becomes 4 over 27, and just leave it like that for right now. Okay. Now here, because you have to do the exponent first, this is a good example. Remember in our order of operations, please excuse my dear Aunt Sally, the exponents come before multiplication. So you're going to do 3 to the 6th. So if you put that in your calculator, 3 times 729, which that is 2,916. Okay, and you can just put this in your calculator, 4 times 3 to the 6th. Okay, it'll do order of operations correctly. Okay. All right, on to a word problem. Okay, suppose an that's totally not what that says. Investment of $500 doubles every 15 years. How much is the investment worth after 30 years? Okay, so we're going to use our formula. Y equals A times B to the X. Okay, 500 is our initial, and that's what A is. Initial amount. Okay, so Y equals 500, okay, and then it says it doubles. So this doubles means 2, triples means 3, okay, quadruples means 4. Okay, so double, so you'd put times 2, and then it says every 15 years. Your X is going to be your time. Okay, well, if it doubles every 15 years, okay, so X here is going to represent 15 years. Okay, so 1 would be 15, 2 would be 30, 3 would be 45. So this would be every 15 years. So if it says worth 30 years, then you would put a 2 up here. Okay, this is part A. Okay, the first one. Okay, so then you would do 500, which I forgot to do this in my calculator, but so 500 times 4, which we know is 4 and 5 is 20. So it's going to be 2,000. So in 15 years, your $500, if you didn't put any more money in, would become $2,000. Okay. Part B, whoopsie, I did too many. Part B, so we just want 5,000 or 500. Part B says that it wants it every 45 years. So it's the same thing, times 2 to the third power. Okay, so 500, 2 times 2 is 4, 4 times 2 is 8. So that's going to be 4,000 in 15 years. In 45 years. Okay, so 4,000 and 2,000. So again, A is your initial amount, B is going to be what it is, the doubles or triples, and then X is your time that you're talking about. Okay, this is the last part. So if it says to graph something, that means you have to make a table. And on these, you have to make 4 points. Okay? Okay, when you go to graph, you have to make 4 points. So we have our chart, our table. Boys, you can walk in here. You just need to be quiet. Okay, so our first, so we have our X, and then we have Y equals 0.1 times 2 to the X, and then we have our Y. Okay, so you need to pick 4 points. 1 needs to be negative, 1 can be 0, and 2 need to be positive. And I would spread them out a little bit. So we're going to make them -3, 0, 3, and 6. Okay, so then, remember you can pick any x's that you want, but they need to cross the y-axis. Okay, so if we have 0.1 times 2 to the -3. Now these can be decimals if you want, or fractions. I don't care. Just put that in your calculator, and you should end up with 0.0125. We're just sketching these, so it's fine. 0.1 times 2 to the 0. Well, we know 2 to the 0 comes 1, so this is going to be 0.1, because 0.1 times 1. And then 0.1 times 2 cubed, okay, which is 2 cubed is 8. 8 times 0.1 is 0.8, okay. And then the next one is 6. It goes up pretty quickly here. 0.1 times 2 to the 6th. Okay, 2 to the 6th is 64 times 0.1 is 6.4. Okay, so again, you're just sketching, so it's okay. Whoa, that line is way off. Okay, so we're going to have 1, 2, 3, 4, 5, 6. Okay, and 1, 2, 3. 1, 2, 3, 4, 5, 6. That's not going to look great. Let's be honest. Okay, so then we just plot them. So -3 is it's very close to 0, so we'll put a point there. And then at 0, it goes up to 0.1, which isn't much higher. And then 1, 2, 3 is 0.8, so it's getting closer to 1. But then at 6, it goes way up here to 6.4. Okay, that's why I make you do 4, because I don't want just these 3. So you got to spread them out a little bit, okay? And then you go like this. Whoop. Try to make it hit that point. Whoop. Whoop. There you go. Okay, and it's going in both directions. So it's exponentially, that means it rises pretty fast. Okay, and this never actually touches that line, but that's a lesson for another day. Okay? So when you go to do the graph, make sure you get 4 points that are pretty spread out. You have to make a table. Okay? And that's it.